For this project, we choose case study of Hamdan steam power plant. Steam power plant are widely used for electricity generation, and coal often used to fuel this plant. Steam power plant consists of boiler, steam turbine, generator, and also other components. Boiler produce high pressure and high temperature steam. Steam turbine convert heat energy on the steam into mechanical energy. Generator then convert the mechanical energy into electric power. Hamdan steam power plant produce about 1000 megawatt output power. Each steam power plant generate about 250 megawatt, composed by 4 low pressure heater, 1 generator, 3 high pressure heater to increase the efficiency of the cycle.
Each power plant unit that generates 250 megawatt is composed of 4 low pressure heater, 1 decanter, and 3 high pressure. Power generating plant basically work on Rankine cycle. The heat produced in the furnace is utilized to convert water into steam in boiler. The flue gases from furnace pass through a superheated where the steam become fully dry. Superheated steam in the delivered to the turbine. Flue gases still have some heat energy in it. Some portion of this remaining heat is utilized to heat up water to the boiler. Feed water pass through the economizer before fed to the boiler. Here, the temperature of the feed water increased by extracting heat from flue gases. After extracting heat in economizer, there is still some remaining heat in the flue gases, which can be further utilized to increase the temperature of air before feeding to furnace. This air heating is done in a preheat. In turbine, high capacity power plant use different stages such height. The steam is equal divide between this unit, high pressure, intermediate pressure, and low pressure. All these are attached to single rotating shaft. This according to the second law of thermodynamics. Temperature of the steam decreases as it flows along the row. Consequently, a great way to increase power plant efficiency is to add more heat after the first stage. After the first stage, the steam is bypassed to the boiler and more heat is added. This is known as reheating. This will increase the steam temperature again, leading to higher power plant efficiency and output. After the exhausted steamer to become condensed, immediately to give space to the steam behind it. This happens in condenser. In the condenser, a streamer of cold water flows through the tube. Steam rejects heat to the liquid steam and become condensed. The condensed extraction pump to the condensed water from the condenser and pump it through the low pressure heater to the decanter. In the decanter, it's actually to remove oxygen that is dissolved in entering water, not entering air. Source of free air include loose piping connection. On the suction side, pump and improper pump packing.
Assalamualaikum warahmatullahi wabarakatuh. Today I will talk about method of performance analysis. My name is Muhammad Afam bin Muhammad alias. First we talk about Exergy analysis. Below is the schematic of the Hamdan steam power plant. In order to do the Exergy analysis, mass and energy balances on the system are required to determine the flow rates and energy transfer rates at the control surface, where subscribes I and E refers to streams entering and leaving the control volume respectively. The Exergy rates of a stream of substance neglecting the potential and kinetic components can be written in the form below. The mixture chemical energy is defined as follow. The last term GE, which is excess free Gibbs energy, is available at low pressure at the gas mixture. They represent the chemical potential at the components at their thermomechanical equilibrium state with the standard ambient for evaluation for the fuel energy. Exergoeconomic analysis. Developing technique for designing efficient and cost-effective energy system is one of the foremost challenges every engineer faces. In addition, many of researchers have developed good methods for performing economic analysis based on the Exergy concepts, which are referred to by a variety of names. Here are some examples of the table about the Exergy distraction rate and Exergoeconomics equation for plant's components. Table for the operating condition of power plant. And the table for the cost function in terms of thermodynamics parameter for the system components.
Good day, Dr. Fatima. I am Lingeshwari Devendran, matrix number B0417110010 from section 9. Would like to present about the performance calculation and suggestion for improvement of Exergy and Exergoeconomics analysis of a steam power plant. First, let me look at the performance calculation. In the aim to determine the Exergy analysis, mass and energy balance on the system should be considered to determine the flow rates and energy transfer rates, where it means we have to apply the first law and second law of thermodynamics to the formula for energy balance, which is the continuity equation, energy equation, and Exergy balance equation. On the other hand, Exergoeconomics is a combination of second law thermodynamics with economics, which is a very powerful technique for designing efficient and cost-effective energy system based on Exergy concept. Second is the suggestion for improvement of the system. The irreversibility rate of condenser is decreased when the ambient temperature increases, which will show the temperature difference between the steam and the cooling air as the dead state temperature increases. This process will decrease the Exergy destruction and hence will increase the Exergy efficiency. If the load increases to the full load, the Exergy efficiency of the components also will increase, which is the maximum Exergy efficiency at the full load. The power plant components that should be considered for improvement of the efficiency are the boiler and turbine. The Exergy destruction in the boiler can be reduced by preheating the combustion air and reducing air-fuel ratio. Designing the boiler and turbine with less Exergy destruction cost will enhance the system's steam power plant performance. Thank you.